So, thank you, Mohan, for this very interesting presentation. Now I'd like to tell you a little bit about how, from the electronics component and system side, we see those potential and huge interactions with the telecommunications or smart network and services community. So, first of all, maybe, okay, where should I point for? Don't know why. Interesting. Good. So I'm going to spend a couple of minutes on what is AENEAS. You might not all be aware of it, of course, and XCCS, the cluster specialized on electronics component and system. Then talk about the electronics strategic research and innovation agenda. Also a little bit about CORE-NEXT, is coordination and support action Mohan already alluded to, and finally, what are the opportunities that we see for joint research and innovation projects between the two communities. Let's hope this works. No, it's still, this is really weird. Yeah, but I'm, oh, okay, yeah, no, I got it now. Okay, so what is our association? So it's non-for-profit industry associations representing our members in the electronics component and system value chain. When we see the members, we go from large industries, small and medium enterprises, but also universities and research and technology organizations. And by whole value chain, we mean from the components, so the chips, and even the people contributing to the fabrication of the chips. So we have equipment suppliers, and we have designers, design automation tools, we have materials, all that, up to where those chips are being used, because we also have, for example, people like the Volkswagen Group or Philips, Volkswagen for automotive, Philips for health, and so on as our members. And our goal is to foster research, development and innovation in order to maintain a competitive position in Europe and help towards the transition towards a sustainable and digital Europe. And so our activities are basically promoting networkings, encouraging collaborative consortium work, and also facilitate to funding support. We are not alone in that, and one of the things that we are trying to do is to engage with what we call adjacent communities. And so when it comes specifically to the telecommunication communities, I would like to mention that we signed last year a memorandum of understanding with the 6G Industry Association, which is kind of our counterpart for the smart network and services. Last but not least, it's not written on the slide, but it is free to adhere to our associations. The membership is free. The only thing is that if you are in a project, in a collaborative project in which we are involved in managing, so basically either XCCS or the joint undertaking KDT, then we will ask a fee based on what you receive as a grant in those projects. Okay, so basically that's also saying what I just said. So the whole value chain goes from the design tools, the materials, the equipment, up to the systems and towards the application. We have over 500 members now. And you can see here in the big circle the logos of the members who are part of our board. And as you can see, it goes from users such as Airbus, Thales, Volkswagen, and so on, down to providers, for example, CELTIC is one of them, and providers of materials, but also the big, let's say, chips manufacturer of Europe, NXP-ST, and Infineon, and also, and it also includes, let's say, RTOs like CELTIC, IMEC, small and medium enterprises like Excelum, and Adimec, and okay, so that's the idea. And where do we position ourselves? I say that we are here to, let's say, encourage a funding landscape which is helping our members and the industry to develop new research and innovation projects. And we are positioning ourselves in the middle of that slide, which shows the funding landscape. At the national level, we know that there are lots of national funding programs in place for the states to help their national companies. And then at the other extreme of this landscape, we have the Horizon Europe program, which is looking at many different different domains, technologies, scientific domains. We are in the middle, so we are involved first of all in Eureka. And as such, we have been in the past managing the clusters Penta and Euripides. Now those clusters are no longer launching new calls, but we still have projects going on that were launched under those clusters, and we are monitoring them. And we are also fully managing XCCS. I'll come back to that later. And then we are also involved with the European Commission, this time in a joint undertaking, Key Digital Technology, and where we are one of the three associations representing the private members in that joint undertaking between the private members, the European Commissions, and the member states. Now, today we are talking about Eureka because we are talking about CELTIC-NEXT, and so there was before a presentation by Katharina from Germany who explained quite well what clusters are, and I assume Xavier did the same, though I wasn't there yet to listen to him for the CELTIC-NEXT cluster. But basically, this is the same construct for XCCS. The main difference is that all clusters are thematic in nature, and our theme is the electronics component and systems. And we are also supported by, and that cluster is supported not only by AENEAS, but also by EPOS and INSIDE, which are the two other industry associations representing the industry in also the KDT joint undertaking. Okay, the important thing is that the basis for that funding program, whether it is for the XCCS funding program or the KDT joint undertaking funding program, the basis is the strategic research and the innovation agenda. And this document is an elaboration of over 300 experts from our domain. The elaboration being driven by the three industry associations already mentioned. And this is really, the idea is that it's a way for the industry to define in a consensual way what they want to work on in terms of research and innovation, what they think the future is and where it needs to be supported. And after that, the calls for projects of those two funding instruments are really based on this. So if you want something to be, let's say, funded within XCCS, it has to be something which is listed within this, document. And the structure of this document is as such, so it's kind of a three-dimensional structure, but of course put onto a two-dimensional slide. So we first have foundational technology layers. So this is a stack going again from materials, equipments, up to the process technology allowing to build the chips. Up there comes the steps of modules and components, modules, and system integration. Then, of course, the software part is also extremely important because chips without software running on it is absolutely useless. and vice versa. Software without chip doesn't run. And at the end, the top of the stack is also the system of systems, so all those, how those systems can interoperate and what kind of technologies are needed there. The second group of chapters in that document is cross-sectional technologies chapters, and here one of them is of particular importance to you, of course. This is a connectivity. So here's the idea for those transversal areas is that either they're benefiting from various technologies developed in the technology stack, or they are used in those technologies. Like another important chapter there is also, of course, the edge computing and embedded artificial intelligence. As we heard, that as we go to 6G, artificial intelligence, I understood, is really a very driving force there. And having artificial intelligence not just in the cloud, but also distributed all over up to the edge is extremely important. And finally, we do have also identified a number of key application areas for those technologies. And here, this is, I would say, the application pool side of the electronics component and system strategic research and innovation agenda. And we have a chapter which is a long-term vision chapter. Here the idea is that these are topics which where the industry is not necessarily ready to work at TRL 4, 5, 6, which is basically the target for the XCCS and KDT joint undertaking programs. But the industry thinks that it's absolutely crucial that there is some funding support, public funding support for those new ideas so that it feeds in the long run the innovation pipeline. So you will see, for example, quantum technologies, quantum computing, software, new algorithms for that would be kind of the things that you would find in this chapter. Okay, so this is a big document. And the question is, how do we identify common ground between this document, which again explains what our community in the electronics component and system is ready to work on, and how do we identify the common ground with the telecommunications industry. The good thing is that actually this work has been largely done in this CSA, so coordination and support action that Mohand was mentioning earlier, and we worked together in this CSA, which is called CORE-NECT, so which was European Core Technologies for Future Connectivity Systems and Components, so basically trying to define what the ECS community should provide in the future to support the development of beyond 5G and 6G, so to deliver, to allow the telecommunication industry to implement the visions that was just presented by Mohand. So this was the major objective of developing a strategic roadmap of these core technologies. Another objective, which I think has been very successful, is also bringing us together, bringing those two communities to talk together. And then third objective is to disseminate afterwards. So we've been doing a lot of dissemination activities, but I would say today is still another opportunity to tell you about that and to tell you to look at it. Okay, as you see, so this is the various, so in the center, these are the people who were part of the consortium. So Nokia and AENEAS are there, as well as what was at the time called the 5G Industry Association, now 6G Industry Association. But of course, many other companies and universities and research institutes have been involved, because we involved more than 100 experts from those different companies in order to come up with the recommendation of that project. Okay, and as I said, one of the exercises that we've been conducting during that project was to look at the ECS Strategic Research and Innovation Agenda and see how it mapped, or where were the overlap or the common ground with the view of the communications industry. And here is obviously most of the common ground you can find in the connectivity chapter. So MC here stands for major challenges for all the chapters that I mentioned earlier in the Strategic Research and Innovation Agenda. We identify major challenges, and here I'm going to identify a few of them which are linked again to the needs for communication. So in the connectivity chapter, we found that we need indeed to work on what we call differentiated, meaning non-CMOS technology development, and that's in order to go to these higher frequency new spectrums that Mohan was mentioning earlier. So you find here, for example, gallium arsenide or indium phosphide, which again was mentioned. Innovative packaging is also very important. Heterogeneous integration. How do you bring the digital CMOS part and the non-digital part in a package? Antennas, going in, up to development of materials in order to have more efficient antennas. Major challenge 2, investigating also innovative connectivity technology, new spectrum or medium, and you see here, again, it was mentioned in the previous presentation, going to 200 up to 300 gigahertz band. How can we even go further later on? New propagation medium, and last but not least, in the green button here, in the green box here is the use of artificial intelligence for efficiency, adaptability, and complexity management. So we are fully in line with what was mentioned earlier. Network virtualization, we've seen also in the presentation of Mohan's that 6G will be a coexistence of many, many networks, and they will have to be in a way virtualized and managed and spread across between the edge and the cloud. Okay, so that was for connectivity. You'll find also in the one of the technology stacks of process technology chapter, a number of major challenges which are also related to the needs of the telecommunications industry. So we talked about, for example, the advanced three-dimensional and optical input-output technologies, and the development also of new embedded non-volatile memory, because also in order to tackle the issues of very low latency, you might need to have in-memory capabilities within the processors that are being developed. Novel devices, again, we see the need to work on these new technologies, or not necessarily new, but let's say pushing the limits of BiCMOS, for example, but also photonics integrated circuits, other devices such as modems, and possibility also to use solid state light emitters. Okay, packaging, of course, heterogeneous integration of packaging is very, very important. Going a little bit up in the stack, here we find in the components, modules, and system integrations also many examples of where we need to develop. I'm not going to go through the whole list here anyway. I assume the slides will be available after this day. Okay. Okay, so I will stop here for, let's say, listing these examples. There are others which have been identified. I'm not going into the details of all of them. But of course, as I mentioned earlier, all the things about artificial intelligence and edge computing is also a very important part, and with all the issues about the energy consumption, which is a big issue of moving to 6G. What I would like to say is that, and you might remember this was one of the objectives listed in CORE-NECT at the beginning, is that the idea was really to develop the links between the two communities. And the good news is that we already have now concrete implementation of these links, because, for example, in the call that was launched in February this year by the Key Digital Technology Joint Undertaking, there is what we call a focus topic, so dedicated budget, which is set aside to support projects which will bring together people from electronics component and systems and people from your community to tackle one of the items that was identified as a priority research item by CORE-NECT, which is working on the radio front end for terahertz communications. So I invite you maybe to have a look at that focus topic because it's currently open. It's still time to apply, and maybe some of you are already engaged with people like ST, NXP and so on, discussing how to make use of that. And my conclusion here is that since it's been done with the, so first of all, that you see that there are many potential synergies for these joint research and innovation projects between the two communities. CORE-NECT has provided a solid ground for you to prepare this kind of joint project. The first implementation, as I just mentioned, is already in place. So to be able to work together is already in place within Horizon Europe. But as was mentioned also by Katharina, we claim sometimes in the cluster, in the Eureka clusters, that we are less red tape, less paperwork than the Commission. So what we've been able to do, let's say within the Commission framework, we should definitely be able to do between each other, actually going even further, because this was not exactly a joint call. This was a call from one joint undertaking, inviting people from another community to join. But in our case, we probably are ready if, of course, the public authorities are supporting us, which is a big if, but or at least an important prerequisite. But if they want to support us, we are absolutely ready to set up a joint call between our two clusters. So with that, thank you for your attention.